Okay, I'd just like to elaborate a little bit on what I was saying in the last video about the attraction between molecules. So what I'm saying is that even though these bonds, these are the covalent bonds, and these are strong, there exists between molecules an attractive force. This is called an intermolecular force. It's something you'll learn more about in grade 11. But it's the reason that things condense when they get cold. I mean, all molecules are attracted to other molecules, at least of the same type of molecule. And so if you are boiling something and it's turning into a gas, this is the attractive force here that needs to break. And if you were to compare this to an ionic compound, you'll see why ionic compounds are usually solids at room temperature. It's because, well, in these ones, there's no ions. There's no charge that is going to attract one molecule to the other. However, if you look at an ionic compound, like say table salt, if you have a positive sodium ion, it's going to be attracted to a negative chloride, as we've talked about, but it's going to be attracted from different directions. A chloride on that side will be attracted to it. Chloride up there and a chloride up there. The chlorides don't want to get too close to each other because they have the same charge. They're all negative and they'll repel each other. But what you end up with is a crystal lattice. Try to imagine this in 3 dimensions, where each of these ions is surrounded by ions of the opposite charge. And these, because of these crystal lattice shape, these are solids usually at room temperature. Okay, in the next section of this, we're going to start looking at how to name covalent compounds. All right, we've learned how to do it for ionic compounds. I think you'll find covalent compounds is much easier. We're going to use the prefix system. These prefixes are found in your data booklet. You probably know some of these already, like mono equals 1 and di equals 2. If you can use your data booklet, you don't even have to memorize these prefixes. The only tricky part here is just recognizing that it is a covalent compound. Once you've done that, it's easy. So if I look at this N2O5, I say to myself, okay, these are both nonmetals, so this is a covalent compound. 2 nitrogens, so that's going to be dinitrogen, and 5 oxygens, so pentaoxide. Oops, or just pentoxide. Okay, next one, CO. Again, recognize that these are both nonmetals. So this is carbon. And there's only one oxygen. So carbon I'm not going to say monoxide, just reduce it to monoxide. You've probably heard of carbon monoxide. You may have a carbon monoxide detector in your house. So notice that we didn't say monocarbon, it's just carbon. This is really the only little rule that you need to remember. If there's only one atom of the first element, you do not need to write mono. It's assumed. Okay, if you have one of the second element though, you do need to write the prefix mono. Okay. So let's see if you can finish these off by yourself. I think it's fairly straightforward, and I can certainly help you in class if you have any questions.